Hi, my name is Akon. Welcome to another QUICKSURFACE demo video. So in today's video, I'm going to show you how to do the reverse engineering of this part. So this looks like a kind of a backrest that you can put on your chair and sit on it. So with the soft memory foam pads, you can protect your butt and your lower back. So you're looking at the scan data of the part, and we're going to use QUICKSURFACE to convert this into a 3D CAD solid. Actually, I've already done this in QUICKSURFACE, so that's the final solid that we have. And as you can see, it's really beautiful. All the features are well represented. So I'm going to show you all the steps that I performed in the history tree, all the way to the final solid body. But remember, this is not a tutorial, so I'm not going to explain all the details of each step. Otherwise, that'll be a very long video. So I'm going to run through each step by playing back each of them so you can have a comprehensive understanding of the whole strategy and workflow. So let's go back to the very first step. I'll just go back all the way to here, and I'm going to show my mesh again. So as you can see, this is a very complex part and will be quite challenging to any reverse engineering solution on the market. And there are not too many prismatic features that we can use on the part besides these ribs and probably the embossed tag in the center. And we also have two little feet here. But beside these, all we have are just irregular organic shapes. So how do we do that? Before we proceed, let's see what we can pre-process the file so we can have a good start. So the very first thing that you probably want to do after importing your file into QUICKSURFACE is to reduce the polygons. So here I reduced the polygon to 600K. So that makes me feel more comfortable with my PC specs. And then I needed to make the part aligned with the system coordinate, like what you're seeing right now. So how did I do that? As I said, there are not too many prismatic features for you to extract with the extract primitives command. So how can we extract something to do the alignment? Fortunately, this part is fully symmetrical, so we can actually create a symmetry plane to do the job. So what I did is to hit the construct symmetry plane. And I'm not going to explain the details, but basically just define something roughly in the center and rebuild with the algorithm in the software to create the symmetry plane. That did give me a decent plane for the alignment. And then we can create another plane on the bottom. So if you have a look at the bottom of the feed, they have small planes. So we can use little areas here to extract a plane. And if you compare, you can see they are actually matching quite well. So with these two planes, we can align the part to the system coordinate by hitting align by coordinate system. So I'm going to skip that because that's the easy part. If you want to learn how to do the alignment in QUICKSURFACE, please go to the official tutorial page and watch the videos. So now the part is aligned and we're good to go. So I'm going to just hide the coordinate. So how do we do this? How do we do the reverse engineering? What commands do we need? So we need to have a strategy, a plan. The best way to do this is to separate the part into different kind of components and model them up one by one. Here, allow me to introduce the selection status of the software. So basically, you can use the edit scan window and a bunch of different selection tools to select the area that you're interested in and save them as a selection status, like the 5 ones listed here. Which 5 ones? What I chose to separate from the part was the lumbar form, which is the one to support your lower back, and the seat form 1, which is this one, and the seat form 2. And I separated the heart-shaped area for the hole making, and then the ribs. So if I double click the selection status, you can see they will be isolated from the mesh. And this way we can, like I said, model them up one by one and combine them together afterward. So let's make this lumbar form first. And here come two very powerful features that you would like to master in QUICKSURFACE, which are the auto surface and the freeform surface. They are actually the same thing. So the auto surfacing allows you to assign some parameters and make the surface very quickly. Like here, we can have the target quad count as 500 and give it a symmetry plane, which is YZ in this case. And we can tick the improve holes boundaries since this is the open non-watertight shape. And by clicking preview, we got our surface in few seconds. But here, I'm not going to repeat that. I'm going to cancel that because we have already done that. And this is our auto surface. So it's basically a one-click operation. And you got a surface matching the shape. If you compare, you will see the surface matching the mesh really well. And it's actually a freeform format. So as I explained, the freeform and auto surface actually use the same technology. So you can use freeform to manually create the surface by placing quads one by one and organize the topology yourself. Alternatively, you can use the auto surface to create one for you and make the necessary modification by double-clicking it to enter the freeform editing window. So this is the freeform editing window. And if you want to learn how to use freeform, please head to the official tutorial page. There are a bunch of different tools and options for you to choose. It's kind of a complicated system for you to use, but it's one of the most powerful modules in QUICKSURFACE. So make sure you get familiar with all the bells and whistles in this window. And now I turn on the mesh so you can see the relationship between the freeform and the mesh underneath. Here you can tweak the surface transparency so you can see the mesh better. You can also change the display method of the mesh. But the point is, after the auto surfacing, you probably need to spend some time to optimize the topology of the freeform and fix some issues if necessary. So sometimes the auto surfacing creates some irregular points or some problematic distribution of the quads, and you need to fix them manually. That's quite normal. Just need to have some patience to do this. So when you finish the editing, remember to extrapolate the boundary a little bit outward by using the extrapolate command. This is to ensure a good trimming or Boolean combination later. So just close this window for now. And well, actually I'm going to go to the setting options and change the rotation method to the relative, because that way I can move my part freely. Okay, yeah, that's better. So here I was just changing the way you browse your part in QUICKSURFACE. So before I was using the other option which pointing the z-axis always upward, but this one I can rotate my part with any angle, and that will make my demonstration much easier. So now we have the lumbar part. I'm going to hide this freeform and go ahead. So that's another one. Well, I forgot to switch to the seat form 1. Yeah, there you go. So the same process, the same steps. So you create a basic freeform surface with auto surfacing, and then enter the freeform editing window to optimize the topology and fix any possible issues before extrapolating the boundary outward. Good. And another reminder here, so if you choose the symmetry option in Auto Surface, probably get the symmetrical distribution of the quads. But if you want to get the real symmetrical editing in Freeform window, you probably want to delete one side of them and reactivate the symmetry mode here. And that way you can set the central line or loop on the symmetry plane and glue them together and make them like a green color here. And this way, when you change the points or lines or faces on one side, the counterpart on the other side will be changed as well. Okay, so this is the seed form 1, and let's make the seed form 2. So the same steps. The only difference between this one and the previous ones is we actually use the crease command here. So you can use the crease command, and as you can see, we have 3 creases here. So the crease command is to make hard edges. If I hide the freeform, you can see the corner of this shape is quite sharp. So if you want to represent the shape better, you can add crease to these edges. And that will make the transition of the neighboring faces G0 instead of G2 on the normal edges. So you have sharp edges. So you will see me using the crease command on the later steps, just to let you know for now. So we just finished the modeling of these 3 pads. Good. Let's start making the body. I'll just hide these surfaces. So the body is made of plastic and probably by the injection molding manufacturing process. And with this kind of process, you usually have an even consistent thickness. So I would say the best way to model the body is to create a freeform surface of the back and then offset that from the word with the thickness. So what I did was to isolate just the back area of the part before I start doing the auto surface and the freeform editing. So if you compare this one with the original part, you can see I actually removed some artifacts from the body, and that includes the heart-shaped area, the hole, and some marks from the injection molding, probably the gates. And I think they are not functional at all, so it doesn't make any sense to recreate them. So just removed all of them. The feet as well, so we don't need to model the feet right now. If I keep the feet and use the auto surface, the topology of the freeform will be screwed, and that will give you much headache. So I just isolated the back side of the mesh and use the edit scan module to remove all the features. Okay, so that gives you a good clean start for the freeform making. So just auto surface the back. You can see that represents the back really well. So here comes the tricky part. Let me just switch back to the original mesh. I'll just hide the freeform for now. So as you can see, the part has a hard edge across the whole thing, just like a skirt or something to make it look better. And the transition is really hard. It's kind of a very sharp turning here. And that's where we should use the crease command that I just described. So let me just go back to the freeform. I'll just double click it. So as you can see, I extrapolated the boundary. So it's an additional layer of the quartz, and the transition here, the whole ring, I just added a crease here so they have a sharp turn. The same principle goes to the editing of most of the other areas. You need to be careful about moving the points when you have switched back to the original mesh. So as you can see, now we have a hole here, So make sure you switch off the snap mode. If you keep using the snap mode, make sure you choose the ray projection option. That way, when you move the points, it's not going to be snapped to anything. You just float there in the space. If you choose the closest point, once you move the point, it will get snapped to something closest to it. And that's not what we want. Same goes to here. So make sure you don't move those points. Otherwise, it will get snapped to the injection molding gate mark. And also make sure you don't move those 4 points. If you need to, place these 4 points outside the feet area. Otherwise, it will get snapped onto the feet. And that's not what we want, because we're going to make the feet separately later. So these are advanced moves in freeform editing. You need to watch the official tutorials to learn how to use all the options that I just mentioned. They are intuitive and straightforward, but you just need some time to learn. Okay, I'll just close the window. So right now we have the back side of our body. And as I said, the body has a consistent thickness. So we just need to offset the back side to the front with that thickness. But how do we know the number of the thickness? So we can try to use the edit scan window again, and we have a clipping box here. So this allows you to create kind of a cross section. I'm going to hide the freeform surface so you can see better. So you can create a boundary that you want to hide the rest of the mesh. So if you hit accept, the other side of the mesh will get hidden. And now you can use the measure command under the analysis menu to get the thickness. So number might jump around depending on which point you measure, but there's about 5 mils. Okay, so just close. And now we know the thickness is 5 mils, so we can do the offset of the back surface. But remember, you need to copy this back surface before you do the offset, otherwise you will lose your back surface. So what I did was copy this one and give this one a 5 mil offset. So the offset command is in this menu. You just give a number of the offset and you're good to go. So this will be our front side of the body. So I'm going to unhide everything of the mesh and then go back to the front surface. So that's the front surface. And this is what we like to see. So the same principle. You want to spend some time moving the points and edges of the freeform to match the front side of your mesh. And make sure not to move those points on the cushion pad areas, especially when the snap mode is on, or you'll be in trouble. So this is what you need to be cautious when you deal with this kind of shape. The front side, you got lots of features that you don't want your freeform point to snap on. So make sure you don't touch those points. Or if you need to, make sure to place those points on the body itself, but not the features like the ribs here. Same goes to the lower cushion pads. And make sure to place the hard edges, which is a creased edges, on the right position, because it might not be the same places as those ones on the back. Okay, so I would say you probably need to spend like 20 minutes or even more on the back and the front surfaces. Just be patient, you can do it. I'll just close it for now. So we have the back, we have the front. What do we do now? We can select both of them and merge them into a single one. But remember, this is not a reversible operation. So what I usually do is to copy each of them and combine the 2 new ones. And that's exactly what I did. So this is the copied and merged freeform surface. And as you can see, this is a solid body, and this is because I bridged the boundary of the front one and the back one. And I also made some extra loops on the edge of the pod to make the surface fit better. Again, if you want to know how to bridge the boundaries of two surfaces and how to split the current chords into a new loop, please watch the official tutorials. So this is what we have, a solid body representing the body of the mesh. So this is what we like to see. It's well presenting the mesh with minimum deviation. And make sure you stay on the symmetry mode. So when you change the points on one side, the points on the other side also change. If your part is deformed, which is quite normal, it might be from the manufacturing process, it might be from the daily use, or it might be from the low accuracy of your 3D scanner, you will always find it's difficult to make both sides matching the mesh perfectly. And that's really normal because that's the nature of reverse engineering. You want to find a point where you have blue color on one side and maybe orange or red color on the other. That way you have a best result averagely. So I need to stress that again here. The reverse engineering is all about reconstructing geometries with correction and meeting the design intent in mind, more than it is about recreating the shape perfectly. In this case, you need to make the part fully symmetrical, which is the design intent. But if your scan data is not symmetrical, it doesn't make any sense to fit that perfectly. Okay, I'll just close this window. So now we have our body. So that's the body of our part. Good. So now we've passed the most challenging part of the whole reverse engineering modeling process. Let's add some details onto our design. So you can see two fit surfaces and the mirrored ones of them on these steps. I'll just fast forward them. So these are areas, they belong to the cushion pads and not part of the body. I thought they were, but if you check the position, you will see they are actually not part of the body. So you need to use other commands to make them. In this case, fit surface. So with fit surface, you can assign an area and just make a surface with it. So that's a fit surface. If I re-enter the window by double-clicking it, you will see a bunch of different options. And by default, you have 40% of the expansion. You can increase that. So that will give you some room for the later trimming. Okay. And now let's make the U-shape area. So it looks simple. You could make that with fit surface as well. But if you look carefully, you will see this area actually has a thickness. So you probably want to choose a more controllable command to make the whole thing. And what I chose was to use the freeform again. I made a freeform of the top surface, copied that, made the offset, and then combined these two guys together. So this is what I have. A freeform solid with the top surface matching the mesh and also a thickness here. So make sure you have a good thickness here, thick enough to make the bottom emerged into the body, but not big enough to penetrate the whole thing. You know what I mean? Okay, just close it. So now we have all the building blocks of the kind of the base of the whole model. We have the U-shaped area. We have 4 fit surfaces. We have a solid of the body And we have 3 freeforms of the memory form cushion pads. And now we can perform a trimming. So it might look straightforward, but before you do the trimming, make sure you check every detail, especially intersections of the parts, and make sure you don't have any gap. So let's do the trimming. So ideally, after the trimming, you get a solid body, which is what we have here. But in reality, you might need to do some work in the trimming window. So what I like to do is to turn on the mesh and then use the apply automatic trimming. And if you make all the CAD components right, once you click the bottom, all the unnecessary surfaces will be trimmed out and you got single solid body. But if the result shows surface body, that means at least one of your components is not perfect. And you probably need to trim some surfaces manually here, or even go back to the previous steps and fix the issue. Okay, I'll just cancel that. And that's the solid body that we have. I'll just hide it temporarily. And what do we have? Now we need to add those details. I'll do the heart-shaped hole here first. What I did was to make a freeform here. So it's easier compared to the previous freeform steps. It's quite self-explanatory. It's a cutter. And then we can turn on the solid body and perform a trimming between them. This way we got a heart-shaped hole. And then we can add a fillet to it, so it looks better. Okay. And now let's start dealing with the ribs. So I have a selection status of the ribs. And this is what we're going to use now. Just hide the body. So how do we make those ribs? If you have a look from different angles, you will start to realize they're actually not easy to make. First, they might not be the same. So the middle one looks smaller, but you never know. So it's better to make them one by one. And second, you can see each of the ribs has a tapered profile. So the bottom is wide, but the top is narrow. So this makes it impossible to use a normal extrusion to make those ribs. So I guess the best way is to create a sequence of different 2D sketches and use a loft command to make the rib shape. And that's exactly what I did. The middle one first, I drew a 3D sketch on top of the surface, and I made multiple sections along that curve. So multiple sections is under the 2D sketch module. Here you can create multiple sections for later use. And in this case, you need to tick the curve guided and choose your 3D sketch. You probably want to change the spacing and maybe offset to some appropriate numbers. You don't want to have 50 different sections and make 2D sketch of each. That will kill your afternoon. So you probably want 4 or 5 sections, and I think that's enough for a loft command. So here's what we have. We have 5 sections and 5 2D sketches. So if you look at one of them, that's a pretty normal 2D sketch. If you hit space, you will hide the mesh and see the reference points better. And I made a closed loop, but that's up to you. So we have 5 sections, and I performed the loft command. Here's what we have. And in the loft window, make sure you expand 2 sides of the surface. So the default value is 0, but as you can see, that's not good for the later trimming. So make sure you expand it, but don't make the expansion too long, otherwise it might penetrate your solid body. So I'm not going to repeat each of them. I'm going to just skip to this step. And now we have 5 surfaces. I'm going to hide the sketches and unhide all the rest of the mesh. And then we can mirror each of them to the other side before combining them to the body with the trimming command. And make sure you still have a solid body after each trimming command. That's really important. If you find it's not a solid, go back to the previous steps and fix the issues. I'll just hide it. And now we can start making the embossed kind of a tag in the center. What I did was to make a freeform simple and then just thickened the freeform with the thickness, as you can see here. So the thicken command is under the freeform menu, thicken freeform. It's a bit different from the previous method that I showed, the offset method. So once you have thickened that, you need to convert that to a normal CAD body before you can do some filleting. So these fillet commands are just to create, these round angles and the chamfer to match the mesh shape. So good. And now, final steps. We need to create those little feet. So the same. I use the freeform to make the basic shape and use a plane to cut it. So this plane, you can just copy the original plane that we used for alignment, and then we just trim these 2 guys. Then I mirrored this one to the other side. Okay, so next up, we combined these 2 solids, the central tag and the body, with the combined command. But remember, you can only combine solids. If you have open surfaces like these 2 guys, you need to use the trim command to combine them. And again, in the trimming window, you can choose to manually remove the unnecessary surfaces, or you can just use the automatic trimming to do the job. And there you go. Okay, so we've already finished the whole modeling of this backrest. It's a long journey, and I know it's not very easy. You need to get familiar with lots of different commands, especially the auto surface and the freeform editing. Very powerful features in QUICKSURFACE and really separates it apart from other reverse engineering solutions. If you can master the freeform editing, you can deal with lots of different complex organic shapes especially. Alright, if you have any questions or if you're interested in QUICKSURFACE or ScanTech scanners, leave your comments below and let us know. Until then, I'll see you next time. Thanks for watching.